Hey everyone, thanks for joining the session today. Uh, this is mainly about EKS Saints Playbook, which will be led by me, who is a subject matter expert and a senior solution architect and ops. And joining with me will be Zach Reinhardt, who is a lead software engineer and Kubernetes optimization architect team head from an ops team, who has built multiple EKS products, including Carpenter spot optimization, as well as the container right sizing optimization for EKS clusters. Hey, Zach, welcome to the stream.
Hey, Sherry, happy to be here. Looking forward to the conversation.
Awesome. It's great to hear. Let's look at some housekeeping tasks here. Today's LinkedIn Live will be approximately 30 minutes long, and we will be discussing generic ideas about EKS cost and scaling challenges that most of the organizations face, and then walk you through with general and practical strategies for right sizing containers, node, and optimizing your purchase types and configurations of your autoscalers too. And all are going to be very generic problems that every organizations face or organization is not aware of. And we'll be taking questions from audience. Please use LinkedIn comments to post any of your questions. And lastly, this session is being recorded and it will be available on LinkedIn. So you can view it again and share it with your colleagues across your organization to increase awareness about EKS optimization strategies and misconceptions and so on and so forth. Let's start. Let's jump in.
Yeah.
Hey, Zach. So many customers talk about EKS tricky. EKS is very tricky to optimize, especially when you are thinking about different layers, different APIs that you have involved within Kubernetes infrastructure. So why is it tricky to optimize? What are the common challenges that every organization faces?
Yeah. Well, on the surface, it's a straightforward proposition, right? You get a control plane that's managed by AWS and your nodes are just EC2 instances. It seems straightforward. However, once you start doing any real world rollouts, things get complicated very fast because you're making decisions about instance types for your nodes and you're making decisions about autoscalers, cluster autoscaler versus Carpenter. You're making decisions about how to configure your resource requests and limits on your pods and how to handle like responsive scaling issues like HPA, VPA, KDA, load responsive scaling, I guess is what I would call that, which is not really what we're here to talk about, but is an added wrinkle. And ultimately, this adds up to a highly complex system that can be very tricky to cost optimize or performance optimize. And also, cost and performance are linked. I mean, there's often trade-offs between a cost optimization and a performance optimization. So you have to understand enough to even make that trade-off. And altogether, it's pretty complicated. It can be very tricky.
And I believe it also involves the organization priorities and challenges on whether the cost optimization is a huge priority or they want to be in the triangle where cost, performance, and also the managing them or moving them around is one of the biggest tasks that many organization wants to look into, right? Jumping into next question or next slide, which is like, what are the common misconceptions we hear? What are the things that we hear from our customers? What are the things we see within the industry wide across EKS experts? What are these misconceptions? Like, how are they real? Are they like myths? What are they?
Yeah, I mean, there's a lot of them. We're just highlighting three of the most common here. One is that moving to spot will solve everything. And I guarantee you, if your applications are tolerant of an occasional disruption and you can move everything to spot, you will save money. But I would not call a poorly tuned cluster running fully on spot an optimal configuration. So that's just one part of the puzzle. Another misconception is that 50% node utilization is good enough. I will say that it can sometimes be hard to even hit 50% node utilization, but I think with today's tools, you can do a lot better than 50% node utilization. And remember, your nodes are what you're actually being billed for. So the higher you can push your node utilization, the better. And another misconception is that right sizing is just about CPU. So even if you're far enough along in your EKS journey that you are right sizing your workloads in some way. You may just be focusing on CPU and driving CPU utilization versus your requests up. But memory is a big factor, and memory can influence how your memory usage can influence how your autoscale picks node types, how you pick node types. There's a lot of considerations beyond just your CPU utilization. And yeah, that's really just at the workload level.
Awesome. Yeah. So I also have seen many of the organization or many of the customers I deal with or see within these organizations, right? People assume that my autoscaler will solve all these problems. It will basically make my Kubernetes optimized. For example, I've met many customers who think that Carpenter will solve all the issues because it uses Spot, picks the instance sizes based on the workloads and stuff. That's true, but it's not. It does a good job compared to other alternative autoscalers in the market, but it doesn't do the best job either. Like, there are many things and many private autoscalers that people just use Carpenter as a wrapper class and just sell them around. But ultimately, it still doesn't solve all the cases and increase your utilization, right?
Right.
We have to look into those utilization patterns and constantly tune what are my workload pattern is, what is their behavior, are they memory intensive, are they CPU intensive, what are the families I need to choose, how should I tune my Carpenter itself is one of the constant thing that customers have to look into. So those are like common misconceptions that where people think, hey, Spot solves everything, or utilization solves everything, or right sizing CPU solves everything, or using Carpenter solves everything. But yeah, it doesn't solve everything. There has to be constant manual effort involved by
Yeah.
engineers at the same time.
Yeah, exactly.
Jumping into next topic, three pillars, right? When you think of the three pillars of EKS optimization, savings is a very big word. We talk about optimization to make sure that when you do optimization, savings is indirectly achieved. And when we think of these three pillars, right, there are three main things that you look into. First one, node right sizing, which we were talking just previously, common misconception, right sizing my CPU will solve everything, but it doesn't. Tuning your autoscaler to pick the right sizes, looking at the patterns and trends of your workloads within that node group or that node pool or that certain group of instances that you're running for a specific set of workloads. Looking at those patterns is very important, and right sizing those nodes and picking the right families and sizes or creating guardrails around that to increase your utilization will achieve you the most benefit because you're not wasting money and you're maximum utilizing your nodes. Again, there are industry standards which ANOPS does for you guys, where we pick the node sizes or just give you insights into how much wastage you have, how you're doing compared to the benchmark, where we assume that 20% of wastage is nominal and understandable, especially in production workloads to meet your performance SLAs and SLOs. But again, you shouldn't be like overutilizing them running at 100% at all times or underutilizing them where your utilization is at 20 to 30% at all times. Having it 80 to 90% is a very great sweet spot that you need to sit at within node right sizing and container right sizing. Obviously, just node right sizing is like, top layer that you're right sizing them and you want to go inside and right size your containers. So as soon as you right size your containers, your node sizes also shrink. For example, if I right size my containers, instead of running like a 4XL node before, as soon as I right size my containers, I'll be running a 2XL node. Right. So right sizing your containers is another important aspect or the category or the pillars that you need to look into to make sure you're optimizing your EKS clusters in every aspect. And finally, and these are ordered in a step process, right? First, no right sizing, container right sizing, and the third one is purchase option. After you do all the right sizing things, then you have to look into, hey, should I go for Spot? Should I go for reserved instances? Should I go for savings plan? Or should I use or take benefit of existing reserved instances that are going unused, or use, if they are savings plan, just push to on demand so that they can be utilized by savings plan. If none are there, using Spot, right? So these are all the main kind of points that you need to look into when you're right sizing or optimizing your clusters. And these are the main three pillars that industry-wide categorizing and generalizing them that we need to look into. And as you can see in the next slide, that how benchmarking is done, looking at the excess capacity, what's nominal, what is the overhead, how you are performing over the size. This is like an example of what NOps dashboard looks like. But in general, this is like an industry standard that every customer has to analyze or within their organization, how their clusters are performing towards the benchmarks and how much excess capacities they have, things around as well. And jumping into the container waste on how to right size them or how to look at them, Zach, would you mind adding a few more points there or some insights around it?
Yeah, certainly. I mean, what you can see on the screen right now is a representative sample of a real world cluster. And I know the text can be a little bit small, but I can highlight here. If you look in the center column, that's the usage column. And then the far right column is the excess column. And if you can't read the numbers, this table shows that this particular cluster has an average. This is average across all the nodes in the cluster. So we actually have an average excess percentage on CPU resources of about 60%, and on memory resources about 40%. And this is an INOPS screenshot, so there's some INOPS cost modeling that's proprietary here that to estimate how much you could save. And it's saying you could basically cut your bill in half by 50% if you could reduce those excesses. So this is just one snapshot. But if you do a little Googling or talk to ChatGPT, you'll find that there are some Kubernetes workload surveys that have been conducted by big observability tool companies. I know Datadog does one that they publish every year. I think there's a few others out there. And if you go look at those surveys, you'll see that this is really what we're seeing on the screen right now is really pretty common. It's very common for CPU and memory to be underutilized across a cluster by 40 to 60%. And that's sort of averaging out across. I think one of the surveys said even production clusters. I'm sure on average, dev and staging clusters have even lower utilization rates because they probably get a little less attention. So there's clearly room to improve here on average. Now, we have also seen at INOPS a few clusters that are highly tuned and have very low excess. And those are typically representative of not only smart tool application, utilizing smart optimization tools, but also, as Shuri said earlier, a lot of manual effort goes into achieving, especially if you don't have smart tool application, a lot of manual effort and a lot of day-to-day operational effort can go into getting those excess numbers up. Automated tools definitely lessen that manual work, and they're an important part of a cost optimization strategy for EKS.
Talking about manual and automated work, what are the advantages and disadvantages of do-it-yourself tools in-house? There are many companies and many customers we meet and organizations we meet that they do in-house. And what are the advantages and what are the issues or the hurdles they need to pass or they need to overcome just to get this properly solved versus what are the automated tools can solve that doing it yourself cannot solve?
Yeah. So let's just talk about container and node right sizing. That's sort of my domain of expertise. And we can start by imagining what the ideal situation would be. And I think we can all agree the ideal situation would be you have some online automatic process that manually adjusts your resource requests and limits and your node selection to keep your cluster running well with a high utilization. Is it possible to do that yourself? I'd say yes, it is. And I can sketch out a little bit of what it might take to do that. The first step, of course, is observability. You need to collect the data about what's going on in your workloads and in your nodes, in your clusters. There are a lot of really strong open source tools to do this. There's Prometheus, which is the gold standard for time series database for monitoring these sorts of things. So you would need something to collect metrics that are relevant. That's the first step. So you're probably going to want to deploy things like Prometheus node exporter to get node level metrics. You're going to need kubestate metrics to get workload level metrics. You're going to need cAdvisor metrics to flesh out that picture. If you're running GPUs in your cluster, you might need NVIDIA's DCGM exporter to get GPU metrics. So you're going to collect so you need to deploy all of those things across the clusters you want to look at. There's Helm charts out there to help you with that. You're going to need a time series database. So Prometheus, Victoria Metrics, Cortex, something like that. we've used, I have direct experience with both Prometheus and Victoria Metrics. I think if I was starting from scratch today, I would probably go with Victoria Metrics. It seems to be, in my experience, basically a drop-in replacement for Prometheus, but with better performance and lower overheads. Okay, so we have metrics collected. We've got them stored in a time series database. The next question is, how do I tell what my utilization is today across my workloads and my nodes? So for that, you can use something like Grafana or other tools. You can build some dashboards. PromQL is sufficiently flexible to extract some statistical measures of how your containers and nodes are doing. You probably will need to look carefully and craft your PromQL queries very carefully to get an accurate picture. If that's not sufficient for your particular use case, you may need to look at custom development there. You may need to be writing some data pipelines or engaging somebody from your data science team to pull your time series metrics and do some modeling on them to gather some statistical measures or some predictive measures. But either way, I mean, so now we have visibility. We know how we're doing. The sort of the last mile is, how do I get that back into my workloads and my nodes? And that is where, as far to the best of my knowledge, there is not a good open source solution. That last mile to close the circle for a fully automated setup, I think, is going to be custom development in most cases. There is, I believe, one open source package that aims to be an end-to-end container right sizing. I don't think it does Node. It's called Crane. It's from Tencent. You can find it on GitHub. My understanding is that that's not been widely adopted across the industry. And looking at their sort of commit history and release history, it doesn't seem like it's under a lot of active development at this point. So I can't really endorse it, but it could be something that you might be interested in looking at if you're wanting to take the DIY route here. So altogether, I mean, if you're looking at fully automated optimization, I would say doing it yourself is a very high effort project. Now, that isn't to say that you can't make some gains without that level of effort. There are some static analysis tools out there that can help you set your resource requests and limits. It's still pretty manual. Like it's like you have to go run this thing and look at the numbers it gives you and manually put them in your manifests. That's probably still better than t-shirt sizing or something like that. And if you focus that effort on a high impact workload, you can still see some useful gains there. But it's still, like I said, it's manual. That's a manual process. So if you're on day 0 of your Kubernetes journey, maybe look at some of those static analysis tools that could be useful to you. But as you scale, especially large production clusters, that's not really feasible anymore to do that level of analysis. So you're either looking at a DIY solution, an end-to-end DIY solution, or purchasing a commercial tool like InOps that can do this, that can do a lot of these things end-to-end with a single Helm chart install. Or, I mean, there's other choices out there, but that's sort of the reason for the commercial tools exist, because the DIY optimization is a high effort process.
I believe, just to add to what Zach has mentioned, the one more point is cost. Looking at these data points does make sense, getting all those metrics and right sizing them, but we have to act on something that's more impactful and achieves more savings. So the only open source model that you can use is like OpenCost out there. But the problem with some of these OpenCost tools, or like this OpenCost agent, is one of the main drawback is it doesn't know or have understanding of what kind of discounts you're having, how much of the wastage you're having, right accurate down to the penny level. So these are like, there are some drawbacks like this, like, you don't have accurate savings measurement, like, accurate impact measurement to find out which workload or which node to be right sized to gain most savings and stuff. So there are things out there, but doing that additional math is something that is not easy for doing it yourself kind of model,
Right.
and also having deeper understanding about cost usage report and grabbing that data and binding it with your open cost data is a very highly skilled job. Unless you have experience with those things, it's kind of a highly skilled and a highly draining job that an organization has to go through, and making sure they have to cross validate it with those data points, right?
Yeah.
So,
I will
Go
also
ahead.
point out from an operational standpoint that OpenCost is designed to run in the cluster it's monitoring. So if you have a large estate, that's yet another workload that you have to deploy across your estate and manage in each cluster and figure out some way to aggregate the results from it. So even if you're happy with its cost modeling, there's an operational impact to deploying it across your estate.
Absolutely. So when you do it yourself, you're just paying to the same amount because you are running like Prometheus servers in your clusters, OpenCost servers in your clusters, running all these node exporters and cost associated to these servers is massive, especially as your cluster grow. These servers will also grow in sizes, and you have to constantly scrape them, bind the data. So there's like a lot of jobs involved if you're doing data processing and stuff. So it completely depends on how much it takes to build, and don't forget the resource cost of human power, right?
Oh yeah,
So a senior architect is spending 10 hours of time. That's almost like $1,000 to $2,000 involved there,
right, right.
versus paying the similar amount to automated tool, taking away all those costs, right? So it completely depends on what's the priority for the organization in terms of like cost, money invested, speed, and so on and so forth. And summarizing what Zach has mentioned, looking at metrics and gathering insights and automating actions and savings are like the regular action we need to take. And this is like what automation does. Zach, would you explain more about this if you don't mind?
Yeah, I mean, this, like I said at the beginning of the last slide, like this is the dream. You gather metrics, you automatically do some modeling and some analysis, some ML maybe, gather some insights, and then you have agents that take automated actions. So that would be tuning your resource requests, maybe your limits. Often requests can give you the most bang for the buck, and maybe your autoscaler config. And if you have this level of automation and it's working well and it's validated, you should see pretty good savings over manually configuring all of this stuff. Like we just said, it can be hard to get this whole process in place with a DIY approach without a lot of effort. It's certainly possible, but it is not a low effort project. And since the cloud and Kubernetes in particular are designed to be responsive and scale as you need them to, that really is another reason automation is important. So even if you have a manual approach that works well, are you going to manually reconsider all of your settings every time you have a significant scale up or scale down event? Probably not. So that's the real value of having an automated pipeline. And that's, I mean, again, a small plug. InOps seeks to deliver that kind of automated pipeline with a really easy onboarding process and get you to that savings bullet on the right as quickly as possible.
Amazing to hear that. So what does good look like? It doesn't matter automation or manual. What does good look like at the end of the day?
I mean, at the base level, you should have your pods right-sized or your containers, because that is the input to all of the other systems essentially. And so that's where that's the foundational thing, in my opinion, in my view, is right-sizing your workloads. And then you can do smarter scaling because you have cluster autoscaler or Carpenter or some other autoscaler, but those autoscalers treat your workloads sort of as black boxes. They don't necessarily look inside that box and say, well, it's requesting 10, but it's only using 1. They just say, oh, it's requesting 10. I'll bin pack based on that. And if you have your bins correctly sized by right sizing your pods and nodes, your autoscaler can work better. And so you can end up with fewer nodes. And if you have none of these things in place, it's likely that your container utilization is all over the place. You may have some containers that are massively underutilizing compared to resource requests. You may have some that are overutilizing their resource requests. You may be seeing kills or other things as a result of that. I mean, kills exceeding limits, but depending on how your autoscaler is set up, it may be juggling things around, even if it sees you exceeding requests. And that's going to result in low node utilization, even if you have a cluster level autoscaler in place. So,
Gotcha.
yeah.
So Where does automation helps the most then, if we think in that way, right? Like ultimately we are gaining like a lot of utilization in optimization in like in nodes, containers and stuff, and we have seen like what are the advantages and disadvantages of automation and manual do it yourself and stuff. So where does automation comes in picture, and exactly where what are the impact points that where automation can deliver the most?
Yeah, I mean, from my point of view, again, foundationally, container and node is a great place to start with your automation. So it would be ideally you would have some automated agent that tunes your requests and your containers, so you get your bins to be the right sized. And then automation at the node level, this can look like, um, for example, the InOps Compute Copilot product will automatically configure your Carpenter or ASG settings to utilize the most stable spot available, or and also make use of compute purchases that you've already made, reserved instances and things like that. And it can help you juggle back and forth between those things to utilize the purchases that you already have. That sort of ties in with purchase logic. There's also other proprietary autoscalers that maybe do more optimization, but they would lock you into a proprietary platform. At InOps, our goal is to work with the open source autoscalers that are already out there to avoid platform lock-in. And we're developing more and more automated features to optimize at the node level as well. And purchase logic is not my primary domain of experience. So maybe you could talk to purchase logic a bit more, Shuri.
Definitely, especially when we think of automation, right? It's great that we are doing container right sizing, we are doing node right sizing. It's amazing to hear that. But there are many organizations out there that have these commitments in place. It could be reserved instances, it could be savings plan and stuff. But looking at this purchase logic, that means, hey, I am 100% covered in my commitments in my easy to spend across organization wide. Now, if I right size all these instances and all these containers, my spend will go lower. So ultimately, I'm underutilizing my savings plan or overutilizing my savings plan, or I might be using spot and wasting the savings plan, throwing away the savings plan utilization or reserved instances away. So when people think of these logics, right, and when you think of automation to like NOps, we actually have that awareness at an hourly level. So we can predict and we can know in real time at this specific hour whether your savings plan is being 100% utilized or underutilized, if your reserved instances are being fully utilized or underutilized, to make sure we are pushing and moving things around from spot to on demand, just to make sure you're not throwing away money. So for example, if there is a customer who's using 50% of their savings plan when they're committed for like $10, and they're using like only $5 of worth of savings plan, and but they are spending like $10 just on an hourly level in their spot. That means we have to move that spot, at least half of that spot usage and half of that spot spend, to on-demand usage, so they can be covered by savings plan, right? So these kind of automation logics, you can doing that at manual hourly level could be very tricky and is a very intensive task, compared to when you think of an automation tool that can do it, that can actually, you're not throwing away money, not just without right sizing or without even doing container right sizing or any of them, just moving them back to on demand and not using spot actually saving you money, because you already committed for a certain dollar value to AWS, right? So these kind of things are not easy to do it yourself, and automation tools are the way to go, are the only way to go for these kind of logics, and so on and so forth. Uh, with this, we conclude the session so far. As mentioned before, we'll have a Q&A session for next couple of minutes. If there are any questions, please drop the questions in the LinkedIn comments, or just post them in the comments of YouTube or X as well. We do have a few questions here. For teams just starting with EKS, where should they focus first? Container right sizing, node tuning, or purchase optimization? So looking at it, something we have discussed in the previous slides, node right sizing and container right sizing are the way to go. And that's the first and foremost focus points that you have to work on before even thinking of purchasing RIs or thinking of purchasing strategies. Right size everything before you purchase or make a commitment to AWS, because there is no way back around once you make a commitment, and never overcommit. So the only way to go is start at node or container right sizing.
Yeah, I would agree. If you're at day 0 of your Kubernetes journey, what I would say is start by right sizing your workloads. Even if it's with static analysis and some open source tooling or very simple back of the envelope calculations using K9s or Lens, start there, and then make sure you have a cluster autoscaler, Carpenter or ASG, or something else if you prefer something else, but it's hard to go wrong with either Carpenter or ASG. And then make sure your Carpenter ASG configuration actually gives the autoscaler enough flexibility to reconsolidate and scale up and down. And that'll give you a lot of bang for the buck right off the bat.
And we do have like one more question I just posted here. How do you combine cost data with usage data to make smarter optimization decisions?
That's a good question. I mean, so usage data alone can help you get your t-shirt the right size, so to speak, right? Like you can go from a container that's only using 50% of its requested resources to a container that's using 80 or 90 or 100% of its requested resources. So that's great, but that doesn't actually give you a lot of insight as to how that's going to affect your bill at the end of the month. So if you have some cost modeling, either from OpenCost or from InOps or some other tools, you can start to make some smarter decisions like, one of the things that we ran into recently, Sherry, remember when we were rolling out our node visibility dashboards, we realized that we had a cluster where our nodes were heavily utilized on memory and not well utilized on CPU. And we were able to seeing that operational data along with cost data, we were able to see, if we switch our autoscaler config to use different instance types for these node pools, we can actually not only increase our utilization, but decrease our hourly cost. And so those kinds of insights are really hard to come by unless you have both the operational usage data and the cost data together at the same time.
And it's quite important, especially in a do-it-your-own way. You have to rely on third-party tools like open source tools like OpenCost and stuff. But it's kind of a complex task, as we discussed before. But yeah, you can definitely do it, but too much tricky to do it yourself. And one final question we have from our customers is there a risk in over-optimizing workloads with tools like HPA, VPR, third-party platforms like InOps and stuff?
Okay, yeah, this is a great question. So the very short answer is yes. So HPA is probably one of the most common load responsive scaling tools out there. So the goal of HPA is not to save you money. The goal of HPA is to optimize for performance, right? And so to use HPA, you scale horizontally. You run more replicas of a given workload and you load balance between them. Well, out of the box, the scaling signal that HPA uses, this is if you haven't configured anything custom, is resource utilization. So straight out of the box, you deploy HPA, you turn it on with default settings. What it starts doing is looking at CPU and memory utilization for whatever workload you've configured it for. And it says, if that workload hits 60 or 80%, I don't remember which it is, but it's in that ballpark. It might be 80%. If the utilization on that workload hits 80%, I need to scale up or scale out. I need to create more replicas. Well, if you're also running VPA on that workload, or you're running a third-party tool like InOps, you have another scaler that's actually actively working to raise that utilization number. So, for example, the InOps container right-sizing product, it actually targets best case scenario. We have some tools to customize this, but out of the box, it targets close to 100% utilization against resource requests. So if you leave your HPA with a default configuration, you're going to end up with these two scalers chasing each other. InOps is going to say, well, let's lower these resource requests to get our utilization number up. And HPA is unaware of that and is going to just look at it and say, oh, we're at 80% utilization, let's add some replicas. And then your average utilization is going to drop, and InOps is going to scale your resources accordingly, and it's going to be this cycle. Now, it's not hopeless. It just requires some tuning. So you have to know that, like, okay, my vertical scaler, whether that's VPA or InOps or somebody else, is aiming to raise this utilization. And with some experimentation, you can still trigger HPA based on CPU and memory utilization to catch spikes in load. But as a very quick rule of thumb, if you're running a vertical scaler and a horizontal scaler, you're probably going to end up with horizontal scaling thresholds that are over 100%, more than likely. And you're probably going to have to do experiments to dial those into your exact characteristics. But it is possible, and you can actually make it work quite well. Now, the best way to do this, and we actually have seen some customers do this with very great success, is to do horizontal scaling based on a signal that's not CPU or memory related. We have a customer that, when they rolled out InOps container right sizing, switched all of their HPA configuration to use custom metrics, and they were actually triggering on packet rate at their network load balancer, which is actually, if you're running a web app in your Kubernetes cluster and that's what you're scaling, that's great. Like, that is the actual signal that you care about, not necessarily CPU and memory utilization. And if you're triggering on a custom metric that has nothing to do with CPU and memory, you won't have conflicts between your horizontal scaling and your vertical scaling. They can peacefully coexist. And in my opinion, you're probably going to get better if you're willing to put the effort in to scale based on custom metrics. Not only can you coexist with a container right sizing tool, but you're probably also going to get better load responsiveness too, if you've got good metrics to scale on.
So that sounds like a very interesting question, and I think we have hit it right on the point. And finally, thanks everyone for joining this session. I hope this was informative enough. And if you still have any more questions, we are available on LinkedIn. You can reach out to me at Shari Talam, or you can reach out to Zach on LinkedIn. Yep. Happy to answer all your questions or give you like a 30-minute consulting session. Or if you're unable to find us, you can also reach out to EnOps website and sign up as a user, and you can reach out to our support team too. And we'll be happy to give you a consulting session as well about just to optimize on how to guide on how to optimize your clusters and stuff. But yeah, I hope this session is informative enough for all the viewers. And sorry for running 7 minutes late, but I hope we were able to give you all those things. Thank you. Have a wonderful day, guys.
Thanks.